Welcome back. The next segment of looking at half-life problems um, deals with working with time. All right, so in the previous video, there's a half-life video that actually works with amounts, but this one I'm going to show you a couple of different ways to actually look at the amounts when your half-life problems deals with time. So if we take a look at problem number 7, tells us that the isotope that we're working with is potassium-42 and it has a half-life of 12.4 hours. What it wants to know is how much of an 848 gram sample of this particular isotope will be left after 62 hours. So here, when you read the problem, rather than there being two amounts, you have two times, right? You have 12.4 hours and you have 62 hours. When you have two time amounts, you want to divide the amount of time that it's been decaying, that is normally the larger amount that you're going to be given, and you want to divide it by the half-life for that particular isotope. So in this case, it tells us that potassium-42 has been decaying for 62 hours and that each half-life is 12.4 hours. So what we've got to find out is how many half-lives has potassium-42 been decaying for. So the way that you actually do that is you're going to take your larger amount of time, which is normally the amount of time that it's been decaying, and in this case that's 62 hours, and you want to divide it by the half-life, which in this case is 12.4 hours. So when we take 62 and we divide it by 12.4, we get 5 half-lives, right? Now we need to use that amount to be able to see how much of the sample is left. So you're going to, here in these problems, you're going to get one amount. So in this case, it's 848 grams. So one of the ways that you can actually do this, and I find that that's probably the easiest way, is that you just want to make a chart, okay, for how many half-lives it's been through. Remember to always start with 0. If you start with 1, you are going to be off by a half-life. So this one says 5 half-lives, so I'm going to start with 0, and I'm just going to label my half-lives down to 5. So 0, 1, 2, 3, 4, 5. 0 times 0 is when everything started. So at time 0, I had 848 grams. And then all I'm going to do is divide it in half until I get to that fifth half-life. So you can see each time, so half of 848 is 424. Half of 424 is 212, and so on until I get to 26.5 grams, which is how much of that sample has been left. Okay, so the other way that you could actually do it, which involves using the graph, is that you could say, I've been through 5 half-lives, go to your half-life curve and say, all right, here is 5 half-lives, and then you have to go up here and you have to try and guess what the percent is that you actually have left, which 5 half-lives, the percent that's actually left is 3.125%, right? And then you have to convert that to a decimal, which is 0.03125%. And you could also take that 0.03125% and you could multiply it by 848, and it would give you 26.5 grams as well. But sometimes if you don't know your percentages really well, this works equally as well, and you're just dividing it in half and you get the same answer. So it's 26.5 grams for number 7, right? We're going to kind of skip over a couple more. Let's go to number 10. All right, so here we're working with carbon-14. They tell you that the half-life for carbon-14 is 5,730 years. If a sample contains 70 milligrams originally, how much is left after 17,190 years? So again, we have two time amounts that we are given. Carbon-14 has been decaying for 17,190 years, and each half-life that carbon-14 goes through takes it 5,730 years. So the first thing you want to do is figure out how many half-lives it's gone through. So we take the larger amount, 17,190 years, the amount of time it's been decaying for, and then we divide it by how long each half-life takes, which is, in this problem, is 5,730 years. When we do that division, we get 3 half-lives. Again, you can set up your chart where time 0 in this problem tells us that we contained 70 milligrams originally, and then we're just dividing it in half each time until we reach 3 half-lives, which would tell us for this problem that we have 8.75 milligrams remaining. All right, and the last one that I'm going to go through with you is problem number 11. The half-life of radon, they tell you, is 3.8 days. A sample of radon has been sitting out for 15.2 days. If the final mass is 6.25 grams, how much radon did we start with? So this one's going to work backwards, but I'm going to show you how that works, and we can do that one just as easily as we have done the other two. All right. Again, you start with 2 time amounts. 3.8 days is how long each half-life has, and this sample of radon 222 has been sitting out or has been decaying for 15.2 days. So we are taking the larger amount, 15.2, which represents the time it's been decaying, divided by 3.8, which is the time each half-life takes, to find out that this sample of radon 222 has been decaying for 4 half-lives. Okay, so again, we're going to make our chart from 0 this time to 4 half-lives. This time, it tells us that the final mass is 6.25 grams. So 6.25 grams would be what we had when we got to 4 half-lives. What it wants to know is, what did you actually start with? So this time, you're going to work backwards, and rather than dividing by 2, you're going to multiply by 2 each time. So this time, it would be 6.25 times 2 to get you 12.5 for 3 half-lives, 12.5 times 2 to get you 25 for 2 half-lives, 25 times 2 to get you 50 for the first half-life, and then 50 times 2 to tell you that the original amount that you actually started with at time 0 would have been 100 grams. So again, this is the video about doing half-life problems when you have 2 time elements rather than 2 gram or milligram amounts, and knowing that you have to take the larger number or the length of decay and divide it by the length of time that each half-life occurs, find the number of half-lives that it's been through, and then create a table in order to find out either the beginning amount that you actually started with or the end amount. If you need the beginning amount, they should give you the end amount, and that is multiply by 2. If they give you the starting amount and you want the ending amount, that's divide by 2. I'm hoping that this video has helped. Thanks so much for stopping by.